Hello everyone, this is your Cisco trainer and welcome you to part 2 of the lecture 5 from the course CCNA 200-301. It is a completely free course to pass the CCNA exam 200-301, and if you like the video, leave a comment and share to help spread this free series of videos. And if you haven't subscribed yet to my channel, stay tuned please by just clicking on subscribe button, thumbs up, hit the bell icon, and do not miss the upcoming notification. In today's lecture, we will cover the following topics. A few of them is already covered in a previous lecture, part 1 of lecture 5. Ethernet LAN switching. We already described about Ethernet LAN switching. In a previous lecture, we discovered and introduced and illustrate one switch. How computer A send frame to computer B on a same LAN or same segments with a one switch. But in today's, I designed this topology in order to gain enough knowledge about Ethernet switching, or PC1, how to send data from one computer to another computers. But the frame or the packet sent beyond the switch, I mean to the routers, either the internets, it is the lecture beyond of today's class. In the future, we will have a separate lectures and also video about how the computer pass packet or send a packet to the internets. So in here we have 2 switch and 4 computers. These beautiful icons are designed at the Study to Master studio. So now let's jump and start. Ethernet frame. As we already know about Ethernet frame, preamble, SFD, destination address, source address, type address that I already explained to you. Preamble and SFD is not considered part of the Ethernet headers, and the size of the Ethernet header plus trailer is 18 byte. Destination address is 6 byte plus source address is 6 byte plus 2 bytes. FCS is 4 byte. Now it's equal to 80 bytes. Ethernet frame. The possible size for an Ethernet frame, header plus payload plus trailer, is equal to 64 bytes. Minus headers and trailer size, which is equal to 80 bytes. From 64 byte, the remaining byte will be equal to 46 byte. Hence, the minimum size of payload is equal to 64 bytes. So if the size of payload is less than 46 byte, then the paying byte will add it at the end of payload. When computer A send the frame to computer B, if the size is less than 64 byte, then it's the functionality of the switch, or it's the functionality of the layer 2 device to add paying byte at the end of payloads. Address Resolution Protocol, or ARP. This network protocol is used to discover layer 2 address, MAC address of non-layer 3 address, Internet Protocol, or IP address. ARP has 2 message or functionality: ARP request and ARP reply. ARP request send a broadcast to all node in the LAN or networks. ARP reply. Reply unicasts to only one node, the node which has sent request, in order to gather those MAC addresses which are not learned in the switch or layer 2 devices. So before we establish the connections, or before the computer A sent the data to computer B, it sends ARP request. This picture is snapped from my computers. This table shows has 2 types of address: static and dynamic. ARP-A, this commands used with Windows, Mac, and Linux. Used to view and retrieve the ARP table, layer 3 address, IP address, example 192.168.0.254. Layer 2 address is a MAC address or physical address 00-OC-29-80-B5-24. MAC address is based on hexadecimal. I means MAC address designed with a system number, the base is 16. But decimal number IP address is designed. IP address or IPv4 address is based on decimal numbers. So this picture shows us layer 2 address and layer 3 address. The ARP, as I told you, has two functions, ARP request and ARP reply. But here, ARP table also show us two types of data, static and dynamic. Static means default entry, which has entered by the systems, and dynamic learned via ARP. So in here, the IP address 192.168.86.254. It is my IP address. I mean, when my computers send ARP requests to the switch to learn this IP address and learn its MAC address. So my MAC address, it's learned by the switch dynamically. Or I have requested and then the switch learned. What is ping? Ping is an awesome network utility used to test reachability on the network, used to measure round trip and times. ICMP also, ping also has two messages. ICMP request, ICMP echo reply. So ICMP echo request send a broadcast to all nodes in the networks. I mean, when we send a broadcast to the network. So syntax for using ping IP address, ping 192.168.0.2, and the result will be shown in the screens. Statics for 192.168.0.2, packet sense is equal to 4, received is equal to 4. Loss is equal to 0. It means we have a good reachability. 0 is loss. Approximate round trip times in milliseconds, minimums 0 ms, maximums also 0 ms or milliseconds, average 0 milliseconds. These are the functionality of commands are used within the switch. Show ARP, used to view and retrieve the ARP table, which associate to layer 3 address, IP address, and layer 2 address, physical address or MAC address. Show MAC address table, used to view the entire MAC address table. Clear MAC address table dynamic, used to remove manually MAC address from the MAC tables or from the table. Clear MAC address table dynamic address is specific if we want to delete the following MAC address, used to remove manually MAC address from a table desirable. Clear MAC address table dynamic interface ID or gig0/2, used to remove manually MAC address from table for a specific interface. These are the commands which we will use in a few minutes, and I will show you how to use or how to illustrate these commands. Ethernet LAN switching. Now in this diagram, I'll show you how PC1 send frame to PC2. First of all, so when the PC1 try to reach to PC4, first it will send an ARP request. So the switch 1 will receive it, then next switch or switch 2. Switch 2 again do the following process. So now PC1 is ready to send a frame to switch. And here we have IP address because we have 2 switch and 4 computers. So first they try to send frame on the layer 3 address in order to gather or to receive, take the MAC address of the PC4 computers. Source IP address 192.168.1, destination IP address 192.168.0.4. MAC address, I just sharded because of the leakage of space. So C201 4255C00C1, it's the MAC address of PC1. C2202 136C00C2 is the MAC address of a PC2, and the same for the rest of computers. MAC address C203 04EO OOC3 is a MAC address for PC3, and C204 42F000C4 is the MAC address for computer or for PC4. Now ARP sequence, source IP. Now try to send an ARP to the switch. Now switch receive the ARP on gig 0/0. The switch process switch 1 now pass or flood this frame to out all the interface except the interface was received. So ARP request has sent to switch 1. Now switch 1 learned. Switch 1 received the ARP request on port gig 0/0 from the MAC address of 00C1. Now switch 1 send unknown unicast to the rest of port. It means to port gig 01 and gig 03. Now PC2 will ignore it because PC2 recognized its own MAC address with the ARP request, and it's fine. So they doesn't match with each other, and PC2 is ignored. Now switch 2 received the ARP request on port gig 0/3. Now switch 2 job and responsibilities start. Switch 2 pass this frame to all interface except the interface it received. So here PC3's ignore, and PC4 because they recognize this ARP is not for the PC3. Now switch 2 learn the MAC and the interface. They received the ARP request on gig 0/3 and from the MAC address 00C1. Now PC4's reply to PC1. The FFFF means it's a broadcast address. Switch 2 broadcasts it to all the rest of interface except the interface it was received. So now PC4 reply. Now it's an ARP reply. The case is reversed now. Before we had the source IP address was the IP of PC1, the destination IP address was the IP address of PC4, and the source MAC address was the PC1 MAC address, and the destination address MAC address was the PC4. Now it is completely reversed. The source address is the IP address of PC4, the destination address IP address is the IP address of PC1. The source MAC address is the MAC address of PC4, the destination MAC address is the MAC address of PC1. Now PC4 send reply to switch 2. Switch 2 learn its MAC address on port giga 0/1 from the MAC address 00C4. Now switch 2 send a reply to switch 1. This process called known forward or known reply. So switch 2 send it frame to switch 1. Now switch 1 received a reply, ARP reply on port gig 0/3 from the MAC address 00C4, which is associated to PC4. Now switch 1 send it to PC1 because switch 1 already learned the MAC address of PC1 on its MAC table. So these are the process of how computers send data from one switch to other switch, or how ARP requests get in place, or how switch know about which computers should to send data, or how they learn the MAC address. This is the process of how they learned and pass the frame to other computers. Now these two computers can pass data. Both switch 1 and switch 2 fill its MAC address. Now communication is established between PC1 and PC2. In this diagram, you should work with your own self. So it's same as previous topology with a little difference on its shape. We have different shape of switch. So these beautiful icons are designed at the study to master companies. Try to do practice with yourself. and install some simulation software or emulator softwares. If you install the simulation software like a packet tracer, it's completely free. You can download it from the netacademy.com. But if you use a realistic software called GNS3 or EVNG, so GNS3 is itself is free, but you use a real Cisco gear inside the GNS3, a Cisco iOS. So you have to pay for Cisco iOS. So it is your homework. Try with yourself, then share your knowledge and check your knowledge with the previous lessons. So in here I have the same topology that we covered on the lecture videos. Here we have with the GNS3. So I already captured PC1 frame, which have sent it to PC4 via Wireshark. So Wireshark is a software which used to sniff or capture the packet or the frames. So in here, I have already marked these two portions. Let's mark this one as well. So what this means? Source, destination, protocol, length, or info. So in here, PC1 sent frame to switch 1. Switch 1 received on Ethernet 01 and broadcasted to the Ethernet 03 and Ethernet 011. Now switch 2 receive on Ethernet 11 and forwarded to or floated to the rest of the interface except the one which was received to Ethernet 02 and to Ethernet 03. It means to PC4 or PC3. Now PC3, ignore it because they already recognized such a MAC address is not same as its own MAC address. Now PC4 send reply ARP to switch. Now let's see AABBCC00100. It is the MAC address of PC1 and the destination is broadcast. Broadcast mean FFFFFF. So it's sent a broadcast address to. What do we have in info? Who has 192.168.04? Tell 192.168.0.1. It means ARP function is asking which PC has MAC address which associate with the IP address of 192.168.0.4. Tell 192.168.0.1. And second line. So here, the source is the MAC address of PC4 and the destination is the MAC address of PC1. It means the first one is ARP request and the second one is ARP reply. Now in here, we have 4 packets, 192.168.0.1 and an ARP reply, ARP request. It is the source address for PC4. With an ARP reply, the source address is the IP address of a PC4 and the destination address is the IP address of PC1. So what do we have inside this packet? Let's check. Let's click on ICMP or ARP. What do we have on ARP? Double click it on ARP. Let's check. As I told you, if the payload size is less than 64, then the pairing add will be added. So in here, this pairing byte already add to this frame. The size of frame you can set by yourself or it's depend on you and also it's default. So in here I have sent it a 46 byte of frame. Let's ARP request. At the source address and the destination address is the broadcast address FFFFF. So the type address of IPv4 0866. Now why we have 6 in here? It means we have packet inside this ARP. So it's the pairing. Now address resolution request for IPv4. Hardware sizes 4, protocol sizes 4 here. Sender MAC address ABBB CC00100. It means it's the source address. So the sender IP address or the source IP address is this. Let's check the others. Destination address. Now let's check the ICMP request. So here we have Internet Protocol version 4. So the flag and the rest of information is here. Source address 192.168.0.1, destination address is 192.168.0.4. If we click on Ethernet, source address and destination address, this is the size, the type of IPv4. Before I showed you the ARP request and ARP reply. Here is the Ethernet frame. I mean the source, the 4 frames sends to destination address and also received by the computers. So these are the information about how packet captures are used. Wireshark are really awesome tools which are used for capturing frames or packet. So let's see as well. So here we have a GNS3 GUI as well. It's a GNS3 GUI. Now let's check the IP address of PC1. What's the PC1 IP address? Show RAN interface E-0 include IP. The IP address of PC1 is 192.168.0.1 and the MAC address is this. Now let's check a switch and how PC1 send data to PC4. So let's check. Ping 192.168.0.4. 4 packet is sent. Now let's check the switch, whether the switch learned the MAC address or not. Show MAC address. In a previous version of the ISO of the Cisco router, there was a dash address table dash. So in new version, there is no need to put a dash. Just show MAC space address table. So these are the entry of switch 1. AABB CC01 00, it is the MAC address of a PC1. So it learned on Ethernet 01 here in this interface. Now what about the PC4? AABB CC000431 or 31, it's the MAC address of PC4. It learned on Ethernet -111 in here. So this is a complete information about how switch learned the MAC address or how we clear this. Now let's clear the MAC address. Clear MAC address table. If we type clear MAC address table dynamically, it means these are learned by switch dynamically. We can assign MAC address statically as well. Show MAC address table. No, there is now no entry for this switch. Again, we send a frame to PC1. Let's ping again PC4. Let's check. Show MAC address. Now PC1 sent data to PC4 and PC4 replied to PC1. So these are the MAC address dynamically learned by the switch. Now what is the function of ARP? Let's check the ARP just by typing show ARP. So we have protocol internet address 192.168.0.192.168.0.4. Aging, it means how many times or how many minutes. Hardware address, these are the MAC address for PC1 and it's a MAC address for PC4. ARP, send and request. Address resolution protocol on Ethernet 00 and Ethernet 00. If I clear, so the function of switch, it's called aging. What's mean aging? After 5 minutes, if the switch not receive any new updates, so the table will be clear or delete all the entries. So if we check, let's check. Show MAC address table agent time. What's the agent time? The agent time of this switch is 300 seconds. It means it's equal to 5 minutes. We can increase it as well, and also we can clear it. So what if we clear the exact address of dynamic address? Which address I want to delete it? For example, I want to delete the MAC address of AABB CC 000511. So I just kept This MAC address, the rest of them I erase it. So here, the total MAC address for this criterion is 1. It means the rest of them is deleted. Now we can delete a specific MAC address of any interface. Interface E0-0. So there is no MAC address. Show MAC address table. So if I do delete this one, Ethernet ET0. So in here I type this command, just put 3. So when we just save one MAC address and I delete the rest of them. So these are the functions how to delete or how to remove or how to make empty the MAC table of the switch. These are the commands that I already mentioned to you. Thank you for watching. That's all for this video. If you want to show your support, please subscribe to the channel, like the video, leave a comment and share the video with anyone else studying for the CCNA.